Ladies and gentlemen, esteemed colleagues and distinguished guests, it's with great honor and enthusiasm that I welcome you to this session. It's called Applied AI Research and Indigenous Innovation. Today, as we gather to explore the vibrant landscape of AI, a realm brimming with innovation and transformative potential. AI, as we know, is not just a technological marvel, it's a catalyst for reshaping the world of developing countries, including our very own rapidly growing nation. The transformative power of AI extends across various sectors, from mitigating climate change to enhancing the access of education and healthcare. It paves the way for creating new job opportunities, fostering emerging industries, and boosting overall productivity and economic growth. Today's session is an extraordinary opportunity to delve into the heart of India's AI research initiatives. We aim to bring together the brightest mind of AI research in India to discuss the latest trends, breakthrough, and challenges in AI research and education. Our speakers will shed light on a wide spectrum of topics, including AI application in diverse domains. Furthermore, we'll also explore latest developments in the AI education, including the integration of AI into academic curriculum. Once again, I welcome you all for the enlightening and inspiring event. May our discussion today ignite new ideas, foster collaboration, and contribute significantly to the global narrative on AI. So before we embark on this insightful journey, I would like to mention that our session today is structured into two engaging sessions. The first part comprises of presentations by our esteemed speakers, who will walk us through the latest developments in AI research, providing a comprehensive understanding of the current landscape. Following this, we'll transition into panel discussion, which will highlight our collective efforts and best practices in creating an ecosystem for indigenous research and innovation in India. However, before we delve into these enlightening discussions, I would like to invite all the presenters and panelists to join us for a quick photograph. So we have here Dr. Balaram Ravindran from IIT Madras, Dr. Partha Pratim Chakravarti from IIT Kharagpur. We have Professor Dr. Parag Singla from IIT Delhi, Dr. Richa Singh from IIT Jodhpur, Dr. Chetan Arora from IIT Delhi, Dr. Partha Talukdar, Senior Research Scientist, Google, and Dr. Madhava Krishna from IIIT Hyderabad. So we'll begin the first part of our session, which is presentations by our distinguished panelists. And so as we prepare to embark on this journey of discovery and dialogue, it's my privilege to introduce our session moderator, Dr. Parag Singla, professor in Department of Computer Science and Engineering. He's also currently heading the School of AI at IIT Delhi. Professor Singla's research expertise include machine learning, deep learning, and artificial intelligence. It is with great respect and anticipation that I now hand over the session to our esteemed moderator. May their guiding lead us into a fruitful and insightful exploration of AI. Thank you. Thank you, sir.
Thank you. Thanks, Sukanya, for the nice introductions. I'll request the speakers for the first session to come on stage. Partha, Richa, Madhav, and Chetan. So the first part of the session will be presentations on applied AI research. We have 4 speakers from all over the country representing diversity in all different ways. So the first session will be by Partha, which is on natural language processing. Let me just introduce Partha. So Partha is a senior staff research scientist at Google Research India, where he leads a group of focused NLP processing researchers. He is also an associate professor at ISC Bangalore. Previously, Partha was a postdoctoral fellow in the machine learning department at CMU. He received his PhD in 2010 in CIS from the University of Pennsylvania. Partha is broadly interested in NLP, machine learning, and in making language technologies more inclusive. Partha is a recipient of several awards, which include Outstanding Paper Award at ACL 2019 and the ACM India Early Career Award 2022. He is a co-author of a book on graph-based semi-supervised learning. So without further ado, I'll request Partha to come up.
Thanks, Parag, Mosam, and rest of the organizers for inviting me here. So today I'll try to give like a quick overview of the NLP research highlights from India. So Parag and Mosam gave me this objective to summarize all of NLP research achievements in India in 10 minutes. I thought that was a ploy to have reduce the number of friends I have, because this is really a challenging task, given the breadth of work that's happening. So big disclaimer, this is my all personal opinion, viewpoints. It's definitely not a comprehensive survey of even of all of the achievements, and apologies in advance for anything that I have missed, right? So when I started thinking about what are some of the interesting things that have happened over the last maybe 22 decades or so, but with more focus on the recent developments. So I consulted a few folks who work in the NLP space and tried to get some inputs from them as well. But before going there, NLP research in India is a very thriving area. There are lots of work happening across many different institutions. There are, of course, many academic institutions, industrial labs, government laboratories, and some of them I have listed here. But then there are many more beyond this. So when I was thinking about how to organize the achievements of NLP in India, so after doing this some of the consultations that I mentioned, I thought of broadly organizing this along these four dimensions. So one is pushing the frontiers on Sanskrit as a language, and how Sanskrit be used for NLP, and developing toolkits and all for Sanskrit. India is a multilingual society, so lots of work in that space. Third one is around knowledge and information, and then finally low data resource and ecosystem. I feel is an interesting working system in India, which is somewhat unique. So I just want to focus on that, and I'll give you some samplings in each one of those four areas. So scientific study of languages in India goes a long way. All of us know about Panini, who did this Astadhyayi back some 2,500 years back, where he formalized Sanskrit grammar. So and then modern NLP researchers in India have also continued that tradition, but with a computational flavor. So in this paper from Rajiv Sangal and his group in IIIT Hyderabad, I guess back then it was IIT Kanpur. So they had a computational Paninian grammar framework. And more recently, researchers at IIT Kharagpur and University of Hyderabad have given even more modern flavors to that, using machine learning and more recently neural network modeling for doing Sanskrit NLP better. So Sanskrit as a language also poses lots of additional challenges. So that frontier is being moved forward. And in my talk, I'll also put this QR code if you want to follow up on that work. So do watch out for those for things that are interested in, right? So now moving on to the second pillar around multilinguality. So just to give you a flavor, I mean, I guess it's already most of us will be quite familiar. So we are a very, very linguistically diverse country. So we have 22 scheduled languages which are recognized in the Constitution. According to last census, we have 1,300 plus languages. We have, I think, around 63 languages which are spoken by million plus speakers each, right? And about 125 languages which are spoken by 100,000 plus speakers each. And then we are also multilingual, and we utilize multiple languages, even in the span of say single sentence, which gives rise to the problem of code mixing, code switching, and all of that. So code mixing is one area where researchers from India have taken the lead, seeing the societal need that's there, and have taken the frontier lead on pushing the boundary on that. So the group in Microsoft Research India, through they have been working on this problem since I think at least 2014, 2015. So where they have released these benchmarks, glucose methods for doing code mixing data, and then that has also led to lots of impact, and there is a community now. So I just shown the workshop on the right hand side, which is in 6th edition right now. So there is a big thriving community of researchers which have kind of like started working on that problem, although that research leadership came from researchers in India. Pushpak Bhattacharya and his group at IIT Bombay have done lots and lots of seminal work in NLP for Indian languages. One of their notable achievements is the Indic WordNet, which has coverage for 19 Indian languages, and it has been very instrumental in developing machine translation and other language technologies. Various communities, including Google and AI for Bharat, I'll talk about that later. We have also released multilingual language models which can support multiple languages just within one model, right? And that has certain benefits because not all languages have equal resources. So having all of these languages being supported by a single model has this kind of like a cross-lingual transfer benefits, and people have utilized these kind of models to build various applications on top of that. The Indic NLP library and the Indic NLP suite also has been very instrumental. So this is a coalition of researchers from IIT Madras and AI for Bharat in particular, Robert Bosch Center, and then Microsoft, which have basically created these monolingual corpora, evaluation benchmark, pre-trained language models, and also the corresponding toolkits in the Indic NLP library, which has been instrumental in developing further language technologies focused on Indian languages. And while many of these things are starting with like an Indian inspiration, a lot of these phenomena are also applicable in other multilingual societies, countries with lots of languages spoken, mostly in global south. So this has also influenced work in those regions. So first was the Sanskrit NLP, second one was the multilinguality, and the third one is knowledge and information. So this is around when you have unstructured data, let's say a document or a sentence, how do you extract meaning and structure out of it, right? So what are, like, say, the entities, objects that are mentioned, what are the relationship among them, so that we can do some advanced reasoning on top of that. So one of the early and seminal work in this area came out of Sunita Saraugi in collaboration with William Cohen. So in this NeurIPS 2004 paper, where they proposed this model called semi-Markov CRF, where they made it possible to kind of assign labels to sequence of tokens and not just individual tokens. And then subsequently, lots of work in the country have happened, which have pushed the frontiers in the area of knowledge graphs, which you can think of as like a way of organizing knowledge about the world, thinking in the form of a graph where nodes represent objects of interest and the edges represent the relationships among them. And there are multiple institutions in IISc, IIT Bombay, IIT Delhi, IBM Research, Google, many organizations have contributed to this line of research in India. One of the key areas where I guess India has taken the leadership is in the area of open information extraction. So usually when you are trying to extract these kind of structures from, say, free-flowing text, you need to know upfront what kind of objects, let's say persons or companies or airports that you are interested in. But defining that schema or those kind of types of objects and relationships that you're interested in often provides a an initial stumbling block or an extra work that you need to do. So the open information extraction turns that problem upside down on its head and says that we don't require any of that schema up front, just by if you give us raw text and we'll be able to extract knowledge out of them. So Mausam at IIT Delhi and Somen and IIT Bombay and their groups have contributed significantly in this area of OpenIE, and also they have made toolkits available which have been utilized by various folks both within India and outside. Okay, so then coming to the last part, which is about low resource and ecosystem. So we all know that data is important, and even in NLP, if you want to build models, you need to have as much data as you can, the more the better. But the problem is that for Indic languages data on the internet, if you look at internet as a source, is minuscule compared to English and other Western languages. So I've just shown you a plot here using a number of Wikipedia articles as a representation of how much data is there across these languages. So in English, we have 6 million plus articles. And then for Hindi, that number is like around 160,000 Wikipedia articles. And then there's a big drop after that. So you have languages like Oriya, which has, I think, some like 10 or 20,000 Wikipedia articles, even though that's being spoken by tens of millions of people, right? So that has been a big bottleneck, and lots of research in India has focused on how we can overcome this kind of like a data sparsity to develop more inclusive language technologies. So one of the important works in this direction has happened in this ACL 2020 paper from Microsoft Research, Monojit, Kolika, and others, where they drew attention to this particular problem and saying that, like, in NLP conferences, we are kind of not paying as much attention to these kind of like low resource settings, and we should be doing a lot more work. So that has actually galvanized the whole research community, and we see like lots and lots of follow-up work in that direction, and rightfully so. In this paper, they also give like a nice categorization of different classes of languages, and depending on like how much data that they are there and in what category they belong based on the data availability. So this is a very good read if you are interested in this particular topic, and has been quite influential. The AI for Bharat, which I mentioned earlier at IIT Madras, has been doing very interesting and important work in this space, where they're creating lots of resources and where they're building models and making it available across like a varieties of speech and language technology problems, be it for transliteration, translation, speech synthesis, speech recognition, and so on and so forth. So if you're interested, there is again the QR code is there. You can go and try out these models, which is available. So this is one effort between Indian Institute of Science and Google, where we are looking at how to capture the speech landscape in India through a project called Vani. The motivation here is that language is a continuously varying phenomenon. Even if you take Hindi, how Hindi is spoken, say, near NCR region, and how that's spoken in, like, say, Eastern UP, there is a big kind of like a variation among that. So if you want to build good, say, speech technology systems, it's important that the model is exposed to all of those variations. So through Project Vani, we are looking at how we can capture speech data from all districts in the country, which will be total about 154,000 hours of speech. 10% of that will be transcribed, and all of that data is being open source. So we are currently in phase 1 in about 80 districts, and from vani.isc.ac.in, you can kind of like get access to the data as and when new tranches of data becomes available. But one of the unique points here is that rather than anchoring on language, this project is focused on doing things in a region-anchored manner, right? Because that's where the ground reality and the variations are there on the language, on the region side. So that's where it's anchoring. And as far as I know, this is a globally unique approach of doing this kind of representative speech data collection, and also the only one that I know at this scale. In earlier session, we heard about Karya. I mean, we know that data is important, but also collecting the data ethically and responsibly, and then paying the data contributors fair wages is really important. So Karya is again a very unique company which is trying to do this ethical data collection and making kind of the data collection as a first order consideration within the AI system. And very rightfully, they were also covered in the front page of Time magazine in August this year. And yeah, I think this is also great to have them in the ecosystem. So finally, government, and in particular METI and other ministries, have been very supportive of development of language technologies in India over multiple decade time frame. And one of the very nice initiatives is this initiative called Bhashini. I guess you may have seen the stalls in the exhibition area, where the idea is to bring all of these data, models, and benchmarks all under one roof, so that it becomes kind of like one hub for everyone to contribute, and it's also easy to build on top of it quickly. right? So I think this is a really nice initiative to bring all of these resources from the various contributors in the ecosystem all together. Now I'll just close with an emerging area about the need for responsible AI, but also doing that in a recontextualized manner, right? So we have heard a lot about responsible AI, but a lot of that research has happened with a Western-centric lens. But as and when you develop these AI models and apply them across geographies and cultures, it's important that the harm that these models could potentially do is analyzed from those target geographies and cultures and language perspective, and then done that mitigation. So that recontextualization is important, and not just kind of like the responsible AI there. So there have been, thankfully, efforts in the country. So the Center for Responsible AI at IIT Madras is kind of like spearheading effort in that direction. And then we are also working on a project called Project Bindi, which is creating this recontextualized NLP fairness, but looking at India as an initial kind of like a geography to focus on. So I think this is really important that this kind of work happens, and I think again researchers in India are taking the lead in this important direction. So there's a lot more to talk about. Of course, I think I'm probably already over time. Parag is looking at his phone for the time, so I'll stop here. And thanks again for your
Thanks. Thanks, Partha, for the very nice overview. Maybe you can have one quick question, one short question. Yeah. One quick question. Yeah.
Okay.
Yeah, go ahead.
Fine. India, people. My name is Sanjay. People use a mix of Hindi and spoken Urdu and English text. Yes. Right. Any solution for that? Yeah. So that's the code mixing problem that I was talking about earlier. But the multilingual models that are being built, where if you have a single model that could support English, Urdu, and Hindi, then you don't have to have these kind of strict boundaries across languages, because the model fundamentally can kind of understand and process that. So that way I think multilingual modeling is particularly relevant in a multilingual society like India because of this intermixing of languages by users. But very good question.
In the interest of time, we'll move ahead. You can take any questions offline. So let me move on to the next part of the session. So the next talk will be by Richa Singh. It will be on computer vision. Let me introduce Richa. So Richa is a professor at the Department of Computer Science and Engineering at IIT Jodhpur. She received her PhD degree from West Virginia University, Morgantown, USA in 2008. And then she joined IIIT Delhi as the first tenure-track faculty member. Her areas of interest are pattern recognition, machine learning, and biometrics. She is also a fellow of IEEE and IAPR and a senior member of ACM. She has served as general chair and program chair of several conferences, including well-known PC chair of, she has been PC chair of CVPR 2022, which is the top vision conference. She has also served as vice president of the IEEE Biometrics Council and an associate editor-in-chief of pattern recognition. She received several best paper and best poster awards in international conferences and workshops. So without further ado, I'll request Richa to come over. Yeah.
Thank you, Parag. Thank you for the detailed introduction. Good afternoon, everyone. Like Partha said, when I got this email, it was an honor for me to be asked to present the research of Indian academics in computer vision, and at the same time it was a daunting task for me, and it took me days and days to figure out how do you present that the enormous amount of body of work that has gone in so many years from so many different researchers across different organizations and institutions. So what I thought was I'll present the research thread on responsible computer vision in the Indian context according to this Pasha's quadrant. So from what I perceive, and this is again my perception and my thought process of things, that research efforts that are there in any space can be categorized into these 4 quadrants, right? Basic research, use-inspired, pure applied, and tinkering. In the Indian context, our researchers have primarily, from the academic community, have primarily focused on the basic research and pure applied research, right? Basic research for developing fundamental responsible computer vision algorithms and approaches for a number of tasks, and then pure applied research tailored for a specific problem statement at hand. And these research efforts have gone into a number of institutions for which you see the logos at the bottom of the slide. A significantly large number of institutions that are there. Compared to the size of the country, these are very, very small, but still there is an enormous body of work that has gone into. So what I'll do is I'll partition my talk into these 2 quadrants and talk a bit about what are the different threads that have gone and what some of the success stories that have gone into that have emerged out of the academics through these 2 threads. In terms of responsible computer vision, today there's a significant focus on responsible computer vision and responsible AI in the global space today, right? And even for the summit itself, responsible is a major keyword. So in terms of, there are several aspects of when we talk about responsible computer vision: bias, fairness, adversarial, and certain others. So in terms of bias and fairness, there are several institutions that are working in the Indian context, and given that a significant body of work in the computer vision and AI space has happened abroad as well. And a lot of data sets. Since morning, I have attended different sessions where we have been talking about data standardization, data regulation. And in this context, when the data, a significant part of the data is coming from Western countries, bias is a very inherent problem. A lot of problems that I have looked at or other researchers have looked at from the Indian context, you see that the models don't perform well, and therefore it is very important to address this perspective to ensure that whatever models that we are building computer vision models do cater to the Indian context as well and to the global community. So bias and fairness is something that researchers are working, including privacy. Privacy concerns are paramount in computer vision. We deal with face images, we deal with images from the medical data. So privacy concerns are very important. The next 2 things are adversarial robustness and explainability. Adversarial robustness is ensuring that robustness is vital, right? Any minor changes or any minor noise should not affect the performance or even deliberate attempts to affect the performance, right? And in terms of explainability, given the research direction that we are in today, explainability is a major phenomena that we need to address. The impact that we're planning to have, the areas that AI is getting applied into, that computer vision is getting applied into, we need to ensure that this happens, right? And there is, again, several institutions are working towards this. Some success stories in terms of bias and fairness that have come out of in the Indian academics. So from Bombay, Amit Sethi's group, he looked at he has been looking at medical data in a major way, and he has observed some of the major variations or interesting scenarios that when the models that you have, the medical models that you have that the fraternity is actually using, the medical fraternity is actually using, it doesn't translate as it is from the Western world to the Indian context. So how do you actually change that? And there is a good amount of work that Amit's group has done. IIT Kharagpur, Abir, and my group has been working on building fair models, inclusive models for face recognition and other problems itself. In terms of robustness, adversarial attacks, deepfake detection, this is again, deepfake detection is something that is recently discussed a lot in the community, the challenges with respect to misinformation, disinformation, all of that. So Venkatesh Babu, specifically at IC Bangalore, is doing significant amount of work on adversarial attack detection and mitigation, and deepfake detection as well, including my group here. This is a PDF, so I don't have the video running, but you can clearly see that this is a figure of Ms. Debjani Ghosh, President NASSCOM. The first figure that you see, it's actually a video of Ms. Nita Ambani speaking something, and using just a few images of Debjani Ghosh, we were able to create a deepfake of Debjani Ghosh speaking exactly what Neeta Ambani is speaking in the top image. So the image is a culmination of Debjani and Neeta Ambani, and the audio is completely Debjani Ghosh's. You can meet me offline to hear the audio, right? So the researchers across the country are doing a lot of work in this space, and again, that concept of bias and everything that I mentioned, again, but the work is happening, but it is very much required for the Indian setup, which researchers are doing. In terms of explainability, folks working in explainability who have heard GradCam would know GradCam was utilized significantly, but from IIT Hyderabad, Vineet Balasubramanian's group proposed GradCam++, which has a significant advantage and is being used significantly in the computer vision space today, right? So, we are doing a lot of work at ISC also. There are work happening with respect to causal inference models and further extensions in terms of explainability that Vineet is still continuing with, right? So this is with respect to basic computer vision research in terms of the responsible computer vision space. There's a huge body of work that has gone into the core computer vision side of things in terms of motion magnification, super resolution, all of that. I have not really alluded to it because in the limited amount of time, there is little that I can talk about, so I've picked up the more recent things that are happening in this space. In terms of the responsible computer vision research with respect to the applied space, from what I see, it could be categorized into different verticals, right? And some of these verticals are autonomous systems, healthcare and better living. Healthcare would be discussed in detail by my colleague Chetan. The other space is biodiversity and wildlife, industry 4.0, sustainable development goals. All of these are spaces where research community is actively participating with different focus, right? So solving and developing critical applications and solving small sample size problems, because for a number of these tasks that you see on this, we do not have the luxury of having very, very large data sets that sometimes we get to hear. For some of the problems, even in all of these verticals you would have, but not for all. So biometrics, or in terms of autonomous systems, biometrics is something that India is proud of because India is running the biggest Aadhaar project, right? Biggest biometrics project globally, which is the Aadhaar project, right? And since that project is running, along with that, there are a lot of other biometric projects that are running successfully. For example, DigiYatra has been running, and I think it's one of the successful ones with this scale, with this environment. The level of success that we've been able to achieve with both Aadhaar and DigiYatra is phenomenal, right? IIIT Bangalore, there is a startup in IIIT Bangalore that is actually contributing to and providing services related to biometric enrollment and identity for a number of countries globally. So that is a major success story, major positive outcome that had come up in terms of biometrics. My group particularly had contributed to identifying the victims of Balasore train accident. So in June, when this train accident happened, there were roughly 200 bodies that were unidentifiable because of lack of documentation on them. So we use face recognition technology to identify these victims, and that kind of opens up all of these things that we have, Aadhaar and the case studies that are related to Aadhaar with Balasore train accident. This kind of opens up a huge space where we can, huge space of social good, sustainability, and support, providing support for these natural calamities and other setups. We are talking about face recognition with respect to surveillance, and I'm sure many of you would have heard a lot of negative instances that have happened globally with respect to the recent Europe treaty that has happened, the discussions on that, right? But from what I see, Indian ecosystem is looking at the positive sides of it. Surveillance will do or not, that's a separate case, but there are a lot of positive aspects to it also that can be explored. So Indian community is also looking at that and trying to provide solutions for that, right? In terms of wildlife monitoring, sustainable development goals, IIIT Delhi, Dr. Saket Anand, from as best as my understanding goes, Dr. Saket Anand's group was the first globally to participate in a global AI-enabled tiger census. So 2019-2020 tiger census that happened, it was an tiger counting. There was an automated effort that went in. Saket led that effort, and since then there are more and more activities happening with respect to wildlife monitoring, wildlife conservation, and recently, along with Saket, we have started looking at bird monitoring, migratory bird monitoring, and other things. So, which has a combination of both co-research as well as application-based itself. In terms of healthcare and better living, IIT Delhi, Bala and Chetan together, they came up with this smart cane for helping visually impaired or disabled persons. We have come up with solutions during COVID for patient monitoring in a home-based rehabilitation environment, for medication management. With respect to medical space, can we come up with early detection or disease and spread and help in infection prevention, right? Stop the spread of infection. This could be with respect to lungs. It could be with respect to other radiographic images or solutions that we can work on. So there are a number of institutions, ISC Bangalore, IIT Delhi, IIT Kanpur, IIIT Hyderabad, that are contributing to this very specific space, right? Drones and computer vision is opening up completely another space which the community is looking at. Precision agriculture, what can we do to help people involved in agriculture, farmers, with respect to identifying diseases and several other things, right? So precision agriculture, IIT Kharagpur has a center on that, and there are other efforts also that are happening with respect to it. Aerial surveillance. Just to give you an example, medicine delivery is one of the things that we were able to do with respect to, when I say we, Indian academics were able to do with respect to drones plus computer vision, right? This was enabled. And in defense, this is happening big time. Defense is big time exploring the usage of computer vision for a number of tasks, be it adversarial robustness, be it target recognition, be it autonomous boats, autonomous anything of that sort, right? Tank identification, analyzing satellite imagery. So there's a lot of scope of, and a lot of case studies that are happening with respect to computer vision in defense applications, and there's a huge amount of scope that exists in that specific space, right? Again, this is something that infrastructure monitoring. So IIIT Hyderabad, Jawahar's group is doing this road infrastructure monitoring where they have installed cameras on different cars, and they are taking data from different cameras installed on different poles and other places to study the environment, to study the infrastructure, the quality of infrastructure in different places, and give inputs to different decision-making bodies and public bodies to actually that the condition of the road is poor, or any kind of challenges that are there that could be that could be addressed. So this is a huge project that IIIT Hyderabad's group has taken up for infrastructure monitoring, and it's not just during daytime. Very simple things. For example, if you're on a highway, the road is bad, there are potholes, there are no lights. How do you go about doing it? So even going to the remote locations of Telangana and neighboring regions and getting data and trying to come up with a framework, not only for just doing computer vision, but also feeding that whatever is there into decision making, into policy at policy level. So that is a wonderful body of work that Jawahar is doing. And industrial outcome monitoring. This is another thing that is happening with respect to infrastructure. So we have a lot of these companies, MSMEs or other companies. For example, companies that might produce ball bearings, or companies that might produce pipes, or any of these sort of things. Monitoring, inspection, quality checking, all of these products. It's essentially a computer vision problem that is being done manually right now, right? So IIT Jodhpur, there is a colleague, Kaushal Desai. He's currently working on automating these processes. So he has come up with devices and solutions to automate the quality inspection and checking of the outcomes and the paths that come along with it. So there's a huge scope, and there's a huge range of things that we are contributing to, and I see a significant amount of scope also. And I think some of these directions, some of these threats that are there will definitely take India from Innovate India to Inevitable India. So thank you for listening to me.
Thanks, Richa. You can have one short question. Maybe someone else. Yeah. Go ahead.
Sir, myself Venkat Reddy. So I have small question. In quality inspection checking, how AI will going to take place?
Can you repeat that?
Quality inspection and checking.
Yeah.
How AI will going to help in this regard?
Yeah, so what is happening is you have these ball bearings. If I take this very specific example of these ball
Exactly.
bearings or pipes being produced,
Okay.
can we you know conveyor belt, right?
Yes,
So
I know.
if we pass them through conveyor belt and put a camera, can you take pictures and check what is the quality of these pictures? You have a ground truth that a good quality pipe or a good quality ball bearing should be of this kind, should look of this kind. There should be no rough edges. There should be this kind of a structure. So you have a benchmark, right? Now can you check that whatever your manual examiner was checking?
I have some particular concern, like,
Okay.
for example, I am from electrical.
Okay.
So motors we will going to use. Motors.
Okay.
Transformers, whatever.
Right.
So in this particular area, is the AI will go into some change?
I think so.
Is there
It's
any-
already happening. I think in terms of transformers and other areas, there are papers that are coming out. I'm not fully aware of the research in that space. I'm sorry, but as far as I know,
Which hang?
So maybe we can take it offline. Yeah.
Okay.
Thanks. Yeah. I think in the interest of time we'll move on. Thanks,
Sure.
Richa. Thanks for the nice talk. Yeah. Okay, so our next speaker is Dr. Madhav Krishna. He'll be speaking on robotics, AI plus robotics. So Madhav is a professor at IIIT Hyderabad, India, and is directing the robotics research there for last 18 years. The center has been funded by several research projects with industries, government laboratories and ministries. He has more than 75 publications in premier conferences of robotics, namely ICRA and IROS, and his articles are very well cited. His main research interests include robotic vision, navigation and learning as applied to autonomous driving, drones and manipulation. Particularly, his contribution in the areas of robotic vision and navigation for self-driving technologies have been recognized by the peer group. During this time, the Robotics Research Center Hyderabad gained international visibility and has been ranked 5th in Asia and within top 40 in the world in robotics research according to CS rankings and airankings.org. So I'll request Madhav to present his slides. Yeah.
Thanks, Parag. I had missed the initial emails which came from GPAI organizers, and then last Sunday, 9 days back, Mausam called me and asked. I never thought in my life I would get a call from Mausam. So I was kind of flattered when he called me. So and then I kind of in that flow I agreed, and then I didn't understand what I'd agreed to. And then I came back and looked at the email. It said I have to summarize the AI for robotics research in this country. And then I was still not sure whether I would. It took a few more days to decide that I would go for it. And then after that, I started, talking to people, and then I approached. I would say like around 10 to 12 universities, and I finally managed to get some slides from maybe half a dozen of them, which is what I would present here. And this is by no means representative, even as a small subset of the kind of activities which happen. There are a lot of startups in the areas of drones and robotic vision, there are too many, maybe especially in Bangalore and Hyderabad area, which I'm not aware. And it was also tough for me to actually ping everyone and get the presentation here. So what I'm doing is not representative, and then it's a caveat. And so I'll start. Right. Having said that, robotics is primarily, it starts off with mechanisms and mechanical engineering and control. The adoption of core AI is actually, people say like what is a CVPR 2020 paper will be an ICRA 2022, right? That's the kind of lag which you see, and in terms of, not in terms of core robotics, but in terms of vision as applied to robotics and learning as applied to robotics, there is always a gap of a couple of years, and that you could see it also in the community. So there are a lot of work which happens in the classical mechanical engineering and control space, which I'm not covering here, classical aerospace, right, and dynamics and control. So those aspects of robotics I'm not covering here. I'm covering more of AI as applied to robotics. So this is a work from Robert Bosch Center for Cyber Physical Systems, and it's a classical examples of combining classical mechanics with RL. The basic idea is if you have a quadruped like this, which has to walk and climb on uneven terrain, the standard way is to develop a mathematical model for the system, a dynamic and control model for the system. That would mean you need very precise system identification, like the mass, moment of inertia, the geometry of the robot, the terrain forces, the way it interacts with the terrain, the friction coefficient, and then you come up with a Euler-Lagrange or Newton-Euler formulation for it, and then solve an optimal control problem. Right, the challenge there is to come up with the right cost function and end up solving the problem. But then, they are typically generic, but then such systems also don't scale up primarily because the system identification is very noisy. The other extreme is to say, I just I give some commands to the actuators, and then I put it in an environment, I put it in a simulator, and then I score a reward and penalty, and then try to learn a policy which will eventually converge to the task what we are trying to do. I think in this case, this is a work of Shishir Kolataya from Bosch Center at ISC. So he combines both classical physics models with deep reinforcement learning, maybe actor-critic or one such network, and comes up with very interesting ways of doing, back and forth motion of the quadruped, lateral motion of the quadruped, steering, and also some kind of uneven terrain navigation. And one of the highlights of this work is that it runs on it just runs on a controller. So the deep RL architecture is pretty lightweight, that it runs on board the quadruped, right? So I think that's one of the highlights of this work, and so you could see that it kind of navigates uneven terrain, is able to move laterally, and then it can also steer itself and do a yaw, and of course inspired from the way humans learn. I don't think we naturally understand Euler-Lagrange or a Newton-Euler mechanism of myself when I navigate, but I still manage to do that. Of course, I don't need to talk, and the big boss is here in front of me, Ravindran, so who does that. So the other work is, of course, in the field of drones. This is a startup, I think, which is based out of Tehran, but localized in ISC by faculty who was in IIT Bombay, then moved to Indian Institute of Science, Dr. Arjun Jain. So this is a drone which is used for warehouse audits. The idea is, like, if you the way the warehouse auditing happens today is you have these housekeeping staff or the staff who operate these heavy forklifts and then go and scan barcodes on these racks and shelves, and then they compare it with the ERP database, and then try to see if there are any missing entries or if there are some kind of theft and things like that. It's always been exciting to use a drone for this purpose, and so the way this drone operates, which I understand from Arjun, is pretty different from the main players in this area, which is Gather.ai and I forget the other company. Is that it first builds a map through a SLAM framework, and then it navigates in this SLAM built map. And it also has a layers of fault tolerance added to it in terms of optical flow based position hold, and then a downward pointing lidar based altitude hold. And then it also can move in very narrow aisles, and then can do some 2D planar lidar based collision avoidance. So it's kind of autonomous, and it can fly through the warehouse and then monitor the barcodes and do ERP planning. Right? So, So this is a video of this drone. So which is obviously flying autonomously, and through these aids able to scan barcode, and I think they have an online way of detecting faults or misplaced items and things like that. In contrast, or vis-a-vis the companies which are the main players in this area. So for any further details, you can contact Dr. Arjun Jain on this aspect of it. So. This one is from Saket Anand. Unfortunately, I think this video still works. So this is autonomous driving and network UGVs. Saket has been focusing on what we call as the last mile problem. So how do you have like a campus shuttle, or maybe even navigating people the last mile from where the airport shuttle drops off to their homes, maybe a kilometer away. So this is a standard autonomous driving platform, but equipped with a lidar, stereo, and other kind of sensors, inertial navigation perhaps, and they have a campus testbed which can go through traffic lights, can detect speed bumps and obstacles and things like that. And another aspect of this work is that they are trying to move, do this networked robotics, where a fleet of robots navigate at this point of time maybe indoors, and then they keep communicating to the cloud, and there is a kind of control from the cloud over these networked robots, right? So this is both these work have been well supported. So this video is worth, I don't know, million images, which may be worth, I don't know now, because you align video, text, and image, so maybe those sayings may not hold anymore, perhaps. So this is driving in kind of rough weather, right? So basically your deep learning methods seems robust for rough weather navigation. And it's a fairly long route which it is covering, and then the route has been mapped through maybe a lidar-based structure from motion system, and you're able to localize in this map, right? So these are challenging problems in mobile robotics, like state estimation, precise localization is not pretty straightforward. And as a matter of fact, deep networks have not penetrated the area as much as they have done in segmentation or object detection. So if you want to, for example, get a 6-DoF pose estimate, velocity estimate, angular velocity estimates, I don't think you use a deep network for that. Right? So it's an amalgamation of both the postmodern learning paradigms as well as classical state estimation frameworks. This is another example where people have adopted AI for solving some very academic but very focused physics problems. So this is from IIT Hyderabad Robotics Research Center, and it's very interesting. So the idea is, how do you balance this kind of quadruped with this vertical stick being, the stick being vertical in the absence of a revolute joint, right? So this neither the quadruped should fall off, nor should the stick fall off, and you need to balance this, right? And so the idea is, so once again there is a RL policy combining with physics-based models, which is able to keep this stick balanced, and so this is another example where traditional mechanism, classical dynamics and control people have started adopting these frameworks for realizing challenging tasks. Right? So this is another example of deep RL in action. So this is navigation of a biped in low friction surfaces. This friction is almost as low as 0.01. And to be able to navigate in such challenging surfaces is not easy at all. And I think perhaps this is maybe one of the first such works which shows how a biped can navigate on almost zero friction, making use of very postmodern machine learning paradigms. So this is another effort from a consortium led by IIT Hyderabad, in which both IIIT Hyderabad and Sri City were part of it. It's a system for it had an ambitious idea of autonomous passenger carrying drone, and it's coming together of several things, like the mechanism design itself. So you have a 16 rotor mechanism, and for a long time there was no off-the-shelf controller like PICSOC which was available. There was no controller for 16 rotor drones, and an indigenous control was developed, and then it finally by the time like PICSOC did come up with the controller, so they used the PICSOC controller, and then there is a lot of motor propulsion happening, and sensor fusion, sensor integration, and then obstacle detection, collision avoidance, and then this was the final drone prototype which took off and hovered, and then also managed to do some point-to-point navigation. And the highlight is also the cabin which houses a person inside. So this is the original animation. Not the final one. This is it's more of a virtual mode animation. So which kind of says the things involved in this process. THAN, of course, is now is well known. It is the one-stop solution for anything related with a plethora of things concerning intelligent transportation systems and autonomous driving. It could be e-bike, it could be a shuttle service, it could be autonomous cars, and also possibly they are entering this unmanned, urban air mobility space, right? So they have a huge infrastructure such as this autonomous navigation testbed, and which has a drone hangar, bus bay, bus stop, pedestrian crossing, smart poles. So anything related to autonomous driving testbed is there in the campus, and they have at least a fleet of cars which does some kind of self-driving on campus. How many minutes? Done. So I'll just one slide or sure, and then so this is finally the work at IIIT Hyderabad in terms of where we have used a postmodern AI for driving, and the thing here is we use OpenSet command. Like in this particular case, we tell the car to navigate to a football field, which is not part of the list of things the model has learned for, but by aligning clip, or rather LSEG encoder to text vocabulary, so it understands football field in this 3D point cloud, and then manages to navigate to this football field. And in this particular case, it manages to navigate to this roundabout in the IIIT campus. So these are not part of the dictionary, or it's not part of what the vision encoder has been trained for, but by aligning vision and text, and fusing it into the point cloud, it manages to navigate autonomously to these places. So with this, I'll stop with the a very small sample set of robotics, AI for robotics research happening in this country.
Thanks. Yeah. We are out of time, but maybe very quick question if there is a burning question.
There was like an industry effort. There was something used by Amazon called Astro, which was supposed to help in the house and kind of keep track of senior citizens. So I was just wondering if you've come across.
I'm not completely aware of the healthcare robotics. There is, of course, Nirav Patel in IIT Madras, who does more like Da Vinci kind of healthcare robotics. But in IIIT, we have a wheelchair which can take LLM kind of commands and navigate autonomously. It today carries a 90 kg or 70 kg payload, and it can take you and if I say like go out of this door and reach this particular cafeteria, it can. But I don't know if you would call that as healthcare, but then the idea is to deploy it in hospitals and things like that. But that's assistive technology, that's what I hear from Chetan. But core healthcare in terms of manipulators, you should possibly talk to Dr. Ashokan from IIT Madras, who does a lot of such work, I think. Yes.
Okay, yeah, thanks. Thanks Madhav. I think we are out of time, so maybe we can move on to the next presentation. So the last one for this session is Dr. Chetan, who will talk about AI and healthcare. Chetan Arora is a professor with the Computer Science Department at IIT Delhi and a joint faculty with the RD School of AI and also with School of Information Technology. He received PhD in Computer Science and BTech in Electrical Engineering, both from IIT Delhi in 2012 and 1999 respectively. He was at Hebrew University, Israel for his postdoc from 2012 to 2014, and Chetan's research interests include trustworthy AI, developing AI techniques for mobility, wearable cameras, cancer detection. Prior to returning to academics, Chetan has spent over 10 years in industry where he co-founded 3 startups, all working on computer vision and products coming out of the latest research. He has published at top conferences, has been PC chair, area chair. So without further ado, I'll give it over to Chetan. Thanks.
My time is over before it started. I just so my time is over before it started. So and yeah. So unlike Madhav, so I sort of sensed it that since I'm the last one, so I will get the least time. So I put my work the first one. Okay. So we'll without getting delayed. So let's start. So just to set up the context, so healthcare is one of the largest sector in India, both in terms of revenue as well as employment. Yet, despite this scale, we are still struggling to provide affordable, accessible, and quality healthcare services to vast majority of our citizens. So that's the background. Now, the modern AI techniques, as we are seeing here, has the potential to transform this healthcare situation in India. We can talk about the virtual consultation, telemedicine, remote diagnostic, monitoring, assistive chatbots, the medical robotics. And I can just go on to a very different stuff, which is the chemistry, the accelerating research in the novel drugs. So there's a whole span that we can possibly cover for AI plus healthcare, and that's why I thought that when I was asked to talk about healthcare plus AI, I said that which context, so the chemistry context, or the robotics context, or the imaging context, or whatever context. And when I'm talking about, I'm not even trying to organize it around the traditional healthcare, whether it's orthopedics or whether it's a cardiac or whether it's a neurosurgery. I mean, it's like that could be a whole different plane where we can sort of try to organize this AI plus healthcare stuff. So what I have tried is, so given that it was becoming impossible to classify, so I said, okay, forget about the classification. Let's pick up some success stories. Okay, the success stories which are centered around India, which to me is affordability and accessibility. So in which cases we have managed to bring the barrier down significantly, let us say. So that's where I try to collect few of the success stories here. So as I said, I'll start with our own stuff so that it doesn't get missed. So this is, for example, the gallbladder cancer. So why I'm saying this affordability, accessibility is that now the gallbladder cancer, as we know, is probably an India-specific disease. One more country, Chile, faces it, nobody else faces it. So absolutely no work done in the AI context in this. So we started doing it with the PGI Chandigarh. So this is, let's say, another aspect which I wanted to highlight in the AI. So this is also, so there are many India-specific problems and we have to solve it. I mean, we as an AI researcher who are working in this healthcare space, we have to pick up these problems and solve them also. So this is what we tried. So the data set is an important part in the AI, so we try to build the data set. And what you start seeing in the table at the below, so the radiologist accuracy comes out to about 70 and 68. And this is what I'm talking about, the radiologist in the tertiary care center. And these are the radiologists that they know that they are going to pick up cancer, no cancer. Now, let's talk about the radiologist who is just looking at the abdominal ultrasound, not aware whether there could be a possibility of cancer here, and perhaps in the primary health or the district hospital. So you can imagine this 70 will go at what place. And then we start working on the AI kind of techniques, and the accuracy starts jumping to 91. So this is the kind of potential that we're talking about, which the AI, for example, the transformation can create. And from the affordability part, or the accessibility part, so we moved it to a device. So the device that you see on your right in the image, and this is a independent device. You can put it along with an ultrasound machine, give it an image, and it starts detecting gallbladder, not gallbladder cancer. Now, this transformation potential can be actually seen across the other stuff also. So this is now what I'm talking about, the mammogram, the breast cancer detection, coming up like a big, let's say the mortality cause, the leading mortality cause in the women now in India after the cervical cancer. And again, you take any models which are trained on the Caucasian data set, no data set in India for the mammography, and you see that the accuracy starts dropping to 50%, 60%, etc. So somebody from the country has to take up this problem that, okay, breast cancer mammogram, we know that it can be done, how to do that. And then we try to work on it, the accuracy starts improving from 61 to 87, for example. And now we are also talking about many of the stuff which are, again, more, let's say, affecting the Indian population. In this case, the breast cancer happens 10 years earlier than it happens in the West, which means that the mammograms that we see have a dense fatty breast tissue, which means that the models are not supposed, whatever the models have been trained on the Western population, will have even more inferior accuracy. And we try to systematically see the problem, understand the problem, and develop the solution, and again put it onto a device which can be given to the hospital. So this is the device now which is being tested at AIIMS Delhi, and giving very good results. So the other stuff that gets missed is the part of the medical skills training. So many of the doctors will, whatever, so before you go to the OT, how many times you have actually done the suturing and see what's the skill that you acquire. So again, with the AIIMS, so there have been this work going on where we are talking about how to give these skills, how to practice the doctor. So we develop the simulators, in this case, for the suturing, the dura, and for the micro drilling, the other kind of simulators. Also for the endoscopy training. So simple simulator which can actually help the doctor get the required skills and not get the skills in the operation theater. And so do the skills, evaluate them, give them the feedback, this is not right, and you do it multiple times, and over a period you get the skills, and then go okay. So the other parts where, so for example, again the affordability, accessibility part. So many of you may have seen that this in the ICU. You have to intubate the patient, and in this intubation exercise, many times the laryngoscope is going on the wrong place, etc., and there is a lot of discomfort to the patient. And this is the work being done by Ishan here. Does it work? So you can simply give a camera, put the camera along with the laryngoscope, and the AI will start assisting you in putting the laryngoscope at the right place. So start detecting where is the esophagus, where the right place to put the laryngoscope, etc. And not only it can tell about the right place, but it can also give you the common understanding of the situation, where is the cyst and where is the other stuff, and less discomfort to the patient, make it right first time, and etc. So this affordability, accessibility can be taken to the other contexts also. So for example, again, this is the work from the biotechnology group here. And we are talking about the ICU on the watch kind of stuff, which you can actually put it on in the primary healthcare center. So there's a watch, and it can do continuous glucose monitoring and many other parameters that you typically find in the ICU, big machines. But now with AI coming to the picture and the sensor advancement, you can actually push it to the primary health on the watch itself. Similarly, the AMR, the antimicrobial resistance, the AMR, is a big problem that is coming out in India. Now, how do you prevent that? You have to really, the first stage, you have to really identify that whether the fever that the patient is really complaining with is a microbial or a viral or a malaria or a thingy, so that the appropriate medicine can be done. So again, the biotechnology group is developing this kind of devices where in less than 12 hours, you actually know which kind of disease or which kind of fever in this case we're talking about, so that the medicine resistance that is getting developed, so we can provide the the antibiotic and prevent this AMR situation. So the other kind of devices that is getting built, so this is now a complete lab on a chip that we are talking about. So various kind of devices for cell sorting, for the molecular diagnostic, for the smear preparation, all this microscopic, the pathology kind of stuff, all done through AI, automated, and which can actually be pushed to the primary healthcare centers. At IIT Kharagpur, so for example, the Devdut, so they are working on the ultrasound cell. So the benefit of the ultrasound is it's available at the primary healthcare centers. So many of these things that in the Indian context, when you want the affordability angle, you may, even if, let's say could have done it through the MRI and the CT, you really want to do it through the ultrasound because that's what is available on the primary healthcare center in which you can do it affordably. So they are doing all this kind of cancer detection, segmentation, simulation, etc. over the ultrasound images. So as I said, the data sets are the big, let's say the inputs for the AI. IIT Bombay, which Richa also talked about, Amit Sethi, so they are working with Tata Memorial Center for creating this whole cancer image biobank for multitudes of many kinds of cancer. I think the immediate focus, which I understand, is on the head and neck and as well as the lung cancer. But the focus of the whole project is to actually collect this data for all kinds of cancer and actually collected longitudinally and across various modalities. So be it radiology, radiomics, genomics data. So they want to collect whole of this data so that we can actually characterize the cancer at all levels. So he's also working on the pathology kind of stuff. So I think, given my own background in vision, I think I'm a little more biased toward the imaging, but I guess I gave you enough indications about the work that is being done in the devices field also. So the healthcare and the AI, so these are highly interdisciplinary fields. So there is no one good expert. So we belong, let's say, from the engineering background, the IIT Delhi side, and we have this aim, so we are on the clinical side. So there's huge interdisciplinary effort required. So we have to teach the doctors the AI and we have to teach ourselves some of the healthcare concepts. So the huge capacity building that is required given this interdisciplinary nature. At IIT Delhi, we have various programs that we are talking about, the MTech in biomedical engineering, imaging technology, and we're talking about the AI kind of stuff, and we're talking about the MTech in mines, MS in biomedical engineering. So huge capacity building that's going on. We have the courses which we are actually co-teaching with the AIMS, so the AIMS doctor can also take some of these courses. We have huge outreach activities in terms of the workshop, etc. going on. And we are not the only one who is trying to build the capacity. So at IIT Bombay also, so we are talking about the KCDH, this Koita Center for Digital Health, and they're also offering something similar. So the UG program in healthcare informatics and the PhD program in digital health, etc. Again, so lots of R&D support as well as the outreach program that is happening through the KCDH. Another stuff, not necessarily from the technical institute, so we have this Tata Memorial Center who's talking about the national cancer grid. Again, so we are trying to approach, we are trying to resolve this problem for the national, let's say that's cancer, trying to create a network of health centers across major cities to really improve this cancer situation, both in terms of diagnosis as well as the palliative care, etc. For the cancer grid. I hope I'm not overshooting the time, and I think it's okay. So I think okay.
Oh, okay. Thanks. Yes. Thanks. We have time for maybe one or two questions.
This is to any of you because I don't know what space it will fall in. There is one indic problem which is very small corpus, very poor context problem and not solved, which is the Indus Valley transcript. And it does not yield itself to archaeological investigations. I was thinking, is there an ML approach to that problem? And has anybody thought or worked on it?
This is for Partha? This is for...
Anybody?
I see. You want to take over? Or?
Yeah, I mean, there is, I mean, I don't know for specifically, like, you know, what's the latest on this, but there are people who kind of like look on like deciphering kind of like, you know, old like these kind of like the transcripts and all, but it's a challenging problem because of kind of like the lack of data and not kind of like very well suited for current machine learning approaches, which are kind of like, you know, more tuned towards like more data heavy. approaches.
Yeah, 469 symbols which are downloadable, but I don't have the full data set of that. So I was hoping that somebody is probably thinking about this problem.
Ravi?
So that's actually an initiative in the Institute of Mathematical Sciences in IIT Madras, where they are actually using AI techniques. They used to work very closely with Professor Airavathan Mahadevan till week before he passed away. He is the world's foremost expert on Indus Valley script, and he has written like huge tomes like this, like 10 volumes of this, all that we know about Indus Valley script, and they were working very closely with him. I don't know the current state of the project, but you should ping IMSE. He probably knows the current state.
Yeah, so some work has been done using information theoretic approaches and AI approaches to figure out what it is. Yeah. The second thing which has been done is the latest results that are coming out are saying that this script has got more connections with Sumerian and Dravidian scripts. So there is some very interesting work in terms of names of animals and elephants and things like that. So there is one chain of thought which comes to the Dravidian script, which is very, very interesting. The more interesting thing that has come out is that it is said that the tablets are not scripts. They are like stamps. They are like postage stamps rather than being a script describing a language. They are like a stamp or a rubber stamp, that equivalent. So they are a culmination of symbols which contain information but which need not be a text.
Which is put out by a private individual. So maybe we need financial and other incentives to go look at it.
Okay. Yeah, I think in the interest of time, we'll maybe close this session here. I guess
one question, if you can take one question.
I think we have another session, so we'll lose out on time on that. So I'll really request that maybe we'll take it
for you.
For Chetan, sure. Yeah, Chetan, Chetan did not. Yes, sure. Go ahead.
So, Dr. Arora, you have told things about diagnostic, right? Being a young country, average population of 35, we've been seeing in the US there's a lot of work done in terms of preventive. So biomarkers, in the world of constant glucose monitors, you can have thousands of biomarkers. You have AI, you can process the data. So is there any work that the IITs are doing in terms of preventive healthcare? Because I think that's important, being a young country who is looking at next 20 years to be one of the giant players globally. I think preventive healthcare would be something that we would be really happy if IIT can come with things together. Thank you.
It's okay. Yeah, go ahead.
Okay. Yeah, so there is a lot of preventive healthcare work that is going on at IIT also in the biotech departments, and so we have this Kusuma School of Biological Sciences also, and but see this slide deck I covered mostly from the friends and the colleagues that I know of, but what I do know also is that these are the kind of work which is also going on in the places like ICGEB and IGIBs. So which are a little, let's say, I would call them more biologically oriented. So we are a little still computational part of it. But there is a lot of work that's going on in the this metabolics and preventive. So that's what I'm aware of.
Okay, I think that brings the first session to close. It's a really difficult task for the speakers to really, cover the breadth of the research being done in India. Let's thank all of them for covering, very nicely what is happening in these areas. I should also mention that there are other areas, of course, where AI is applied, whether it is agriculture or smart cities or climate. I guess we chose 4 of them based on availability and also given time. So let's again thank the speakers. Switch gears now. So we'll request the next set of speakers or panelists, Professor Ravindran and Professor Chakravarti, to come on stage. So I should quickly mention about the next session. I should say that for good research and innovation to happen, educational institutions are very important. And what has happened in last few years, multiple such centers of AI, excellence in AI, have come up, whether it is at IIT Madras, or IIT Kharagpur, IIT Delhi, IIT Gandhinagar, IIT Guwahati. So next session will be about the initiatives which have been taken at these places and best practices and how we can learn from them. So next session will be moderated by Chetan. I'll be part of the panel. So I'll request Chetan to introduce speakers and carry from there.
Okay, so we'll start the next session. So we have a panel here comprising of Professor P.P. Chakravarti. So I would like to call him PPC. That's okay. And we have Ravindran. Let's call him Ravi, I guess. And we have Professor Parag Singla, and let's speak the Parag. So I'll briefly give an introduction about all the three panelists, and then we can start this session. So the PPC completed his BTech in 1985 and PhD in 1988 from Department of Computer Science and Engineering at IIT Kharagpur. He then joined the same department as faculty member in 1988 and is currently professor there. He has also served as a director at IIT Kharagpur from 2013 to 2019. So he asked me to give a shorter introduction, so I'll just skip to the major achievement that I would like to attribute to him. So he was the visionary behind the National Digital Library of India project, leading that as a project investigator. He was also the coordinator of the global initiative of academic network, the GYAN scheme as we know it, as well as many other places. So he's a well-respected researcher in this area. Coming to Professor Ravindran. So Professor Ravindran heads the Robert Bosch Center for Data Science and Artificial Intelligence, as well as the Center for Responsible AI, the CARI at IIT Madras. He is the Mindtree Faculty Fellow and Professor in the Department of Computer Science and Engineering at IIT Madras. His research interests are centered around learning from the through interactions and span the areas of geometric deep learning and reinforcement learning. He received his PhD from University of Massachusetts, Amherst, and his master's degree from IISc Bangalore. He's a senior member for the GPAI and an ACM distinguished member. Coming to our third panelist, Professor Parag Singla. He's a professor in Department of Computer Science and Engineering and is also currently the head of School of AI at IIT Delhi. He received his bachelor's from IIT Bombay, master's and PhD from University of Washington at Seattle. He spent about a year and a half as a postdoc at University of Texas at Austin, before starting as a faculty member at IIT Delhi in 2011. His research expertise include machine learning, deep learning, and AI. He has done extensive work in the subfield of statistical relation learning and has done some great work in applying machine learning models to problems with societal impact. His research focus recently has been the area of the neurosymbolic AI, which aims to combine the power of symbolic reasoning with neural models. Authored many papers, 50 papers in top tier paper, including NeoRIPS, ICLR, etc. He has also been a recipient of Vishwesharaya Young Faculty Fellowship from Government of India. And we can start with the panel discussion. So the way we have planned this session is that we'll give the speakers about 2 minutes each to briefly tell about the individual unit that they have centered around the AI in their respective places. So Parag for IIT Delhi, Ravindran for IIT Madras, and PPC for IIT Kharagpur. And then we will formally start this session where I have few questions for our panelists, and that should initiate the discussion. Yeah.
So in 2018, we realized that though there were a lot of people working in AI and there were about 10, 12 courses in the computer science department, but there was a huge requirement and a need and an urge for students of other departments. The computer science courses were primarily meant for the computer science students who knew all these courses from architecture to networks to OS to algorithms. So we set up this Center of Excellence in AI with the primary aim for targeting non-CS students. And the way we curated it was we defined 5 courses. One was Math for AI, one was Stat for AI, one was AI and Applications, AI Foundations and Applications, one was ML Foundations and Applications, and one was Deep Learning Foundations and Applications, and then there were electives. And initially we had just a few 2-3 core faculty members which we hired, and then people from other departments. And we started the following programs. we set up what is called a micro specialization in AI, which means that any student of any discipline who does the 3 of the core courses and a project will get what is called a micro specialization, which is a little less than a minor, but in the degree it will be written BTech in chemical engineering with micro specialization in AI. And they can do their thesis or their project work anywhere. And they don't need to apply for anything. If they just do these courses and clear everything, automatically they get the micro specialization. No administrative overheads at all. So within these 3-4 years, every year we get about 80 to 100 people doing micro specialization in AI. Secondly, teachers from other disciplines started pouring in, and then there was a need to start a dual degree, the MTech. That means if you do a BTech in any discipline, science, engineering, doesn't matter, you can get an MTech in AI, provided you go through a sequence of courses from your 2nd, 3rd year onwards, and then your thesis is done. And what happens is, in the thesis, you can have a supervisor from any department, including your own. So there is a huge community of, associated faculty members, about 15, 20, and target areas were defined. For example, thematic areas, as everybody has said, vision, language, etc., etc. And among the target areas was obviously healthcare, manufacturing, transportation. One of them was judiciary and things like that. So today we have a large number of students doing this micro specialization. This is independent of the computer science students. So this has brought in a completely new dimension to AI in IIT Kharagpur.
Thank you. Thank you. Ravi?
Yeah, so I'll save a few seconds walking to the podium. And despite the insidious attempts on the name board, don't believe them, I'm still at IIT Madras. Okay? So I've dropped everybody's attention to the name board now. Nobody was looking. Anyway, fine. So at IITM, we have been looking at, obviously, like Professor PPC was saying, so AIs should not be a preserve of just the computer science department, right? So there are a lot of people who are very much interested in looking at, the applications of artificial intelligence in their domain. So we started this Robert Bosch Center. In fact, even before that, in 2015, we started an interdisciplinary lab for data science, which brought together people from 6 different departments, right? So we looked at, research areas that were cross-cutting with applications across these departments. So the departments range from chemical engineering, biosciences, transportation, as well as management school and computer science and electrical engineering. So these were the departments that got together and started this initial interdisciplinary lab for data science that kind of evolved into this Robert Bosch Center for Data Science and AI, which currently has representation from 13 of the 18 departments that are there on campus. So the faculty from 13 different departments who get together, work on various research projects. And we have 150 plus researchers and about 35 faculty members who are part of the center, who have a secondary affiliation to the Center for Data Science and AI at IIT Madras. So we run numerous degree programs. So we have a minor in artificial intelligence, very similar in spirit to how Professor PPC described it. So you don't have to apply for the minor. You do the sufficient number of courses, then you get the minor in AI. And we also started back in 2018. We started this dual degree program in data science and AI. We call these interdisciplinary dual degree program. And so the students apply to transfer to this program in the 3rd year, and they get both a bachelor's in their parent discipline as well as a master's in data science and AI. And right now it's a very thriving program with 75 students per batch. And so we had multiple batches already graduated out. And that's been a very active community that's being set up. And apart from that, more recently, we started the Center for Responsible AI, where we have taken this whole idea of interdisciplinarity much further. Because when you start talking about the impact of the technology on society, right? So we really have to get more people involved than just the technologists, right? So at the Center for Responsible AI, so we have lawyers, we have economists, we have social scientists, we have civil society, we have policymakers. Everybody has a platform. We have a lot of adjunct faculty at the center who come from very different disciplines. We have even a couple of lawyers, right, as adjunct faculty at the center. So we're trying to, make sure that there's a much more broad-based discussion on how AI should evolve from here, right? And this is probably going to feed into more curriculum and courses coming up. And so finally, an announcement is that we also are starting a new department of data science and AI at IIT Madras. And so that would start offering undergraduate programs and master's programs, and as well as MS and PhDs in data science and AI as well. It's been approved and everything, so you'll soon start seeing it in media. I'll stop here. So.
Right. So I guess our journey has not been very different, a little bit behind in the race, they say, right? Great minds think alike, right? So just looking at IIT Kharagpur, Madras, actually even other places like IIT Bombay, IIT Delhi started School of AI 3 years back, and started with the idea that there should be a center of excellence in AI, which could do some research around AI and bring those people together. But once there was a call out to all the faculty members, we realized, in fact, my colleague Mausam, who is not here, he was the one who sort of spearheaded. Of course, there are multiple of us who were with him in the team. And we realized there is large group of faculty members who are interested, not just from CS or E or maths, typically the disciplines which do AI, but from all across, the same story, I guess. And we came together, there was a lot of support from the institute and the government and industry that there should be one place or one nodal agency, right, where you talk about AI, what is happening in AI. And that's how we started. We have a master's program, both MTech program and Master of Science for Research. There is also a PhD program. There is about 40 plus faculty members who are associated. There is 16 or 15 joint faculty members and others who are associated. And I think what has happened is this has really helped bring these people together. And I can say more when we do more question answering discussion. Many different research initiatives have come about, which I think might not have been possible if the center was not there. Maybe I'll stop there and then we can have more discussion as the questions proceed. Thanks.
Yeah. Chetan, can I get a couple of more minutes to talk about the two other major initiatives that are not represented here? So. Sorry, yeah. So I wanted to just call out Indigenous of Science. So they started much before all of us. They have this Department of Computational and Data Sciences, and which has been having a significant focus on data science and AI, apart from having activities in other departments. And apart from the CDS department, they also have a division of electricals or whatever, the AI thing, where multiple departments come together and teach a program on MTech in AI. Right? It's not offered by a single department, so it's offered by multiple departments. So that is another very vibrant AI community that's there in India. And of course, then IIT Bombay, as Parag called out, also has the Center for Machine Intelligence and Data Science called C-Minds, which again, I believe has 70 plus faculty who have a secondary affiliation with C-Minds across multiple departments in Bombay, and they offer both a master's program in AI and as well as a dual degree program, just like all of us do actually. The interdisciplinary dual degree program, even IIT Delhi offers that, and so does IIT Bombay. So just calling out.
Yeah, thank you. So I will move on to the questions that I have for the panelists now. So the first, I will come to the academic part later on, but let's first talk about the impact of the centers on the research ecosystem and the innovation. So at IIT, we still do collaboration. Different departments are allowed to do the collaboration with the industry, etc. So the CS people will do, let's say, the research collaboration with the like-minded industry, etc. Now, what do you think when we create a center, for example? What is really the impact on the research ecosystem, on the indigenous innovation that we're talking about, which you think would not have been possible if we were split across, let's say, the department boundaries, or the traditional department boundary, the CSE, maths, and other stuff? Any thoughts, any comments on this, what you have seen?
So, like you rightly pointed out, right? It's not like we are not allowed to collaborate with the industry or anything. So what, at least in our experience, we have seen is, we have this group of people from disparate backgrounds coming around and having these discussions, right? And now, when an industry partner comes in and says that, look, I want this problem solved, which a computer science faculty alone wouldn't be able to solve, it's much, much easier for us to reach out to a colleague who would help us complete the team. So now we are actually seeing industry projects being undertaken by interdisciplinary team of faculty, which would, I mean, it's not that it is not possible, but it would have been harder to put together a team like that earlier if you didn't have this interdisciplinary dialogue going on already, right? It also makes it easier for the industry to approach us because we have a kind of a single stop where they can come and talk to people and then figure out what is the direction that they want to go in. So that's been one big change I see.
So my learning from this is that we have seen the other disciplines drive the whole innovation system, whether it's friction stir welding, or whether it is atmospheric monitoring, or whether it is a point of care disease detection. All this has come from the discipline or the biology, which actually meant that while after an initial interaction with us, they learnt up both computer science and AI faster than we could learn up their disciplines. So it actually shows that most of these core engineering and science disciplines are harder to assimilate than machine learning and AI. And therefore, we are seeing unique applications and ideas coming out from mining engineering, from agriculture engineering, and things like that. So that is one thing. The other thing that has come up very interestingly is that students even cross boundaries more. That means there in the student team, it's not just a computer science with a mechanical engineer. It is an electrical, mechanical, computer science, economics, and everything together. So they have broken boundaries, and they are doing even better and at a faster pace.
I can definitely second. See, I have 2 PhD students who are MD radiologists. It has been easier for them to pick up the AI term for me rather than to pick up the medical terms.
Yeah, I think that point is very well said. I mean, even at IIT Delhi, that has been the experience. The faculty members and students alike, they have picked machine learning like anything. I think probably the bar for us to pick that is probably higher. So that is one. I think another, the way I would answer this is, for any good research to happen, I think there is faculty collaboration and students. So I would give my own example. So there is a colleague in chemical engineering who sent me an email while back, several years back, that we should just talk. I was so busy with my own research that I never had time to talk to him. I feel bad about it. But once the school started, we naturally started seeing each other in terms of student committees, admissions, so on and so forth. And the ideas sort of started, bumping around, and we started discussing. So I think, as they say, a lot of interesting collaborations happen over coffee or dinner, right? And the school or such virtual or real space gives you an opportunity to talk to such people. So that is one thing that happened. Second is that because now there is a mandate, right? We call it AI plus X, right? X is any discipline and AI is the core AI or machine learning. Then naturally we admit students who are not doing only AI but also thinking about the specific disciplines. But now once we have students, right, often we discuss that once we have a student who has the right mindset, naturally the research is geared towards that. So those 2 things I would say are really facilitated by School of AI, which might not have been possible without such a center in place. Yeah.
I mean, I was talking more about the industry part because you explicitly called out saying how the collaboration happened in the industry, but certainly the academic environment has also significantly changed. And in fact, more than 70% of my students nowadays are not from a computer science background. So, and that certainly happened. I also have to correct one mistake that I made. So I want to also call out the oldest modern AI center, which is the Kohli Center that's there in IIIT Hyderabad. So they have been at it at least a year longer than us at Chennai. So
I think IIT Guwahati also is.
That's new. I said I'm just calling out the oldest of the modern thing.
Thank you. Thanks. So what I'm let's say, if I try to summarize what I gathered from this discussion is that true. I mean, the researchers or the faculty were let's say collaborating with each other, but blurring this boundary, bringing them onto one platform actually fosters the collaboration between them, makes it easier, and also makes it easily visible to the industry so that they can just come to the center and really do that. All right. So now let's move to this, the second question that I have. So this center versus department discussion. So, so some of the IITs have managed to open centers, some are calling schools, and some have departments now. So where do you think, so at what stage we think is having a department of AI, or, I mean, so I use the AI and data science as interchangeable here, department of AI or department of data science, whatever you call it, is you think is the right move? Or because now you have already bitten the bullet, so what do you think are the arguments in favor of, okay, this is the right time to start the department of AI? Because at IIT Delhi, at least, we have not yet bitten that bullet. Any thoughts from each of you?
No, man, But I would really like to hear Professor PPC's take on it, but let me go and tell you what changed our. So it's not just a question of, just adding a name to it, right? It's not just a question of calling a center versus department. So IITs have certain statutory roles for some of these, and it varies from IIT to IIT. So for example, centers in Delhi, right, or in Bombay, I'm not sure about, correct? But so they can hire faculty.
Maybe I'll just clarify myself. So when I say the department, I say the BTech program in AI also. So that's
okay. So the BTech program in AI, then we should probably ask before they already have a BTech program in AI running much longer than.
Yeah. So just the thought. I mean, so some of the let's say the IITs are still holding on to not starting the BTech in AI, just calling them schools and.
So I think at this point, right? So there is sufficient differentiation because of the nature of the field itself. For example, if you take computer science, right, the kind of math that we teach the computer science student is not sufficient for them to get a very good grasp of even the fundamentals of machine learning and AI, right? So we really have to go back and teach them more optimization, even starting from more calculus, linear algebra, probability theory, and they don't really need to know graph theory or discrete math, which are the fundamental math courses that are being taught in computer science. And similarly, even if you start thinking about correctness of algorithms or analysis of algorithms and so on and so forth, right? So we don't think about like this big O notation for the ChatGPT models and things like that. So when you start talking about correctness and about data-driven way of problem solving, right, as opposed to the more algorithmic approach to problem solving, there are different ways in which you can talk. There is still a significant overlap, but at this point, I think that is enough material that we really need to put in. We can put in and create a sufficiently differentiated curriculum. In fact, even more differentiated from CS than IT curriculum was, right? And I think it's a good time to start, and there is demand in the market for sure. So I think it's a good time to start this.
Okay, thank you. PPC.
Computation became spouse of every subject. Computational physics, computational chemistry, computational biology, computational linguistics, computational economy, computational psychology. It was the spouse of every subject. Because there was the subject matter and there was computation, which aided knowledge in that subject matter. AI has taken that subject itself and started doing on language, image, text, theory, tomorrow formula, day after tomorrow theory. So AI is going to replace that subject itself, is what is the fear. All subjects are going, see, if you look at AI has usurped everything. They have taken statistics and called it data science. They have taken algorithms and called it symbolic AI, etc., etc. So, I think I agree with Balraman that Ravi, that the time for a separate BTech in AI has come. But I also feel that AI is such a subject that you will need a person in a core discipline to have a micro in AI. You will need a person who has done any discipline to migrate into AI, and you will need computer science people to do AI. You will need all these three in addition to building a new AI group. So this is different from how computer science spawned off from electronics and became one discipline. AI is going to infiltrate every discipline and yet remain a BTech in AI. So we're going to have everything.
Yeah. But maybe we can just let Parag.
Okay, so I guess it's hard to differ from two experts, but I would honestly say I have been sitting on the fence in terms of the UG program. I mean, it's very clear that AI is going to be there. I don't think it's one of those fads, right, which will stay only for 5 years and something will sort of disappear. I think it's going to be there. But I think for a UG program, I feel that there has to be something core to that discipline, right? For example, when computer science was sort of shook off from electrical, right? I was probably a small child, but people tell me that no, there was a reason that no, there was an algorithmic component which was different from electrical. So I do think that maybe the time has come, but I think we also need to do a lot of deep thought and hard work in terms of how it will be different from just amalgamation of courses from these three disciplines, but something new has to come out, right? It cannot be just a sum of A, B, C, where A is maths and B is electrical and C is computer science, but something which is unique to AI. So that's sort of my take on this.
Yeah, any answers for the Parag's question?
No, I was going to actually add on to what Professor P.P. was saying. So when you say we are starting in a department, right, it's not just question of just having the undergraduate program. We're also thinking of more innovative ways of designing graduate programs that allow people. So I like this concept in the UK where they have this whole idea of this transition or bridge masters and things like that, which allows people from different disciplines to transition. So we have to think about all these activities, which are a lot easier to handle when you have something like a department. Yeah, but and our answer Parag's point, yeah, yes, just wait for our complete curriculum to come out. We have put in thought to make sure. Yeah. So I have a small request. Can we ask Richard?
Yeah, that's what I was about to say. So we have many experts on the floor also. So please feel free to add your comments or questions.
No, very specifically her, because her department has been running a BTech in AI for a while.
Even Madhav, if you want to add about the Kohli school.
No, they don't have a BTech in AI. I mean, I'm just specifically about this question, just for that question.
IT Jodhpur's philosophy has actually been what PPC just mentioned, right? We have a BTech program which is kind of an amalgamation of maths, computer science and AI. What we have said is computer science and maths are very much essential along with AI, because after discussing with a lot of industry folks, this is what we realized, that even today when a student goes to industry, which a lot of BTechs do, you don't do 100% AI. You do 60-70% computer science and you do 30-40% AI. So you need to know algorithms. You might not need to know big O notation, but you need to know algorithms, graphs, all of those data structures and all of those. And plus, along with that, we have this minors, right? So a mechanical engineer who wants to engage into AI, we have a lot of these paths open for them. So mechanical engineer, civil engineer, any of those, except computer scientists actually, have an option to take a specialization or a minor in artificial intelligence. So they can take up to 5 courses, or they can take even more. 5 is the minimum. They can take 5 courses in AI. There are 7-8 credits of core, plus there's some electives which they can take, and they have a minor in AI. And on top of that, our MTech AI is actually not restricted to just computer science. The intake of our MTech AI is very, very open. So we take everybody. Right, we even take MSc statistics, we take mechanical engineer, civil engineer, any of those. It's just that we have added quite a few core courses from AI and computer science, because when you come into the system, you need to know algorithms, you need to know a few things. So 3-4 courses of computer science and AI are there, which are core. Plus on top of that, you can do a lot of other elective AI courses depending on what your interest is. And your thesis could be an intersection of your major, which was in BTech. It could be mechanical engineering, AI on top. So your MTech thesis could be a combination of both. So that kind of a flexibility what IIT Jodhpur is providing. So we are kind of in sync with what you're saying.
Yep. Thank you. Okay. Yeah, please.
So I have vested interest in making sure the panel doesn't run overtime. I have a flight to catch. So.
Thank you. I was talking to Dr. Richa earlier. I would like to specify a problem between industry and the institutions. Okay. Let's understand there is a subject called quality management system. Okay. And there is an international standard called ISO 9001. It's very popular otherwise. Now institutions took many years to adopt elective chapter on total quality management many years later when the standards was published in 1987. Now recently, 2023, ISO, International Organization for Standardization, has published a standard called Artificial Intelligence Management System. It's called ISO 42000 series. If you're developing the schemes, developing the BTechs and MTechs and in your prestigious institutions, this subject will help the students who may be in the final semester like that. And before they are graduating or post-graduating, they can take benefit of this management system theory approach of AI, and they can apply into the management system. Now, where I come from, a quality management system, like for example, I did the mechanical engineering. Now, I started working in the industry. 6 years down the later in the industry, I realized when I become a quality assurance senior inspector or manager, I will realize that, oh, I should have known quality management system. You know, that's where I'm coming from. Thank you.
Thank you. Thanks. Well understood. Okay. So in the interest of time, I'll just come back and cover a few of my other questions that I wanted to ask. So the discussion is now increasingly coming around this AI and the applications part of it. Okay. So let's say that the center is also the center or the department, whatever we call, is also focusing on AI, and as Richa is saying, so we want to take the people from diverse background because of this application focused. Now, let's say an academic institution, let's say IIT Delhi, just for the example, starts the school of AI or the department of AI, and we want to take in the PhD student, the graduate student, or the faculty. When you say that the focus is on AI plus X, what is the criteria that you wish to apply for this recruitment? So who gets admitted? What are the basic minimum requirements that you would like to pose on the intake, both from the student side as well as the faculty side?
You know, AI is such a discipline that it has a place in every discipline. So you cannot have a straitjacketed rule for creating such things.
Absolutely.
You have to have an open mind and flexibility. The core content here is that if it is AI plus X, then we expect the X faculty who is supervising this PhD, there must be a person in X who will supervise this PhD. And if that person does not know sufficient AI, then there must be a CS or an AI guy. Or what we have adopted is that if you have such, then you need people from 2 disciplines to supervise this student. And we are trying to evolve a mechanism in which departments are in a formal partnership with the AI center, in the sense that they will jointly offer courses, they will jointly take PhD students and things like that. So you can come from any such discipline and work in AI. That is the plan.
Okay, so let me ask a very even more pointed question. So does an incoming PhD student in Department of AI or School of AI need to know programming beforehand?
That is the only thing as of now we have allowed, that they need to know programming. That is the only prerequisite till now.
Probability?
No.
Okay.
The only requirement we have done is, I'll tell you, the entrance exam in the Center for AI for PhD has got a math portion, a programming portion. I think just these two, a math which involves probability, and basic IQ test.
Yeah, okay. So what you're saying is the admission test typically involve math and programming.
Math, programming, IQ.
Yeah, okay. Ravin.
So just to clarify, your question was about the students or about hiring faculty?
Actually both, but I mean you can answer one by one. So what is the criteria or what you apply for the students,
okay,
like the PhD students, and let's say for the
so right now we have a GATE paper on data science and AI, right? So if you look at the kind of curriculum there, it's basically a lot of math, some amount of programming, and it also has some basics of, very, very rudimentary machine learning kind of idea. What is, some simple things on classification and so on and so forth. Not necessarily getting into the techniques and so on. People have to understand that. And if somebody who's gotten through that kind of a GATE exam, right, so that they come through a master's for data science and AI, that would be a great fit for to get into this program, right? So if you are going to run a separate entrance exam for people who want to get into master's or PhD, right? So we are already doing that in IIT Madras. So we have many master's programs which kind of predate the GATE paper that's just come out, right? So we have been selecting people, and largely we have been having a programming component, and we do this all online. So they go to some portal like Code Tantra, they actually code and run and we see the output and so on and so forth. And math and aptitude, and more on their idea of how they handle data, right? Not necessarily grill them on machine learning or anything like that. Those are the kinds of components that we put in for the graduate programs, and something similar for the PhD programs would be there, right? But we also work with a lot of students from other departments. So for example, at our center, we have PhD students who come from chemical engineering background. So they would know only programming, but they would then pick up AI on the fly. And like you said, right, it's easy for them to pick up the AI part than for us to pick up the chemical engineering part. So this is where we are with regard to the students, right? So fairly flexible in terms of getting them on board. With regard to faculty is another question, right? So what we are looking at is not being very particular about the discipline in which they have earned their degrees, but looking at what their research focus has been. Have they been consistently working on this using data-driven approaches and using AI, ML kind of approaches to solve problems in their domain, right? And if they have a good publication record in that field, right? So these are the things that we are looking at, and we are not going to be very hung up on the actual graduating discipline. So you could come from electrical engineering, you could come from an aerospace background, or you could even have a management PhD, right? As long as you have been working on data-driven approaches and as well as AI, we are happy to consider this application.
Okay, Parag, you have any?
So I think IIT Delhi is similar in that sense. For example, for PhD admissions and even for MSR or masters, right? They just need to take GATE, for example, and it can mean any discipline. Doesn't have to be, now there is a new GATE exam in data science. Also, there is a lot of discussion even for masters program, but we said, let it be any of these GATE exams. Doesn't have to be data science or computer science or electrical. So in that sense, it is fairly flexible. I should add that we do face a little bit of challenge. At least some of the students who enter the program, often they have a different background than CS or EE or maths, but once they come in, they want to do core AI, right? So that expectation has to be aligned, and I think some work has to be done there. In terms of faculty also, I think just like Ravi said, that faculty should be doing some data-driven or machine learning or AI-based work mostly, right? And they can be from any discipline. So I think in that sense, it is fairly flexible. One question I would just like to add, which I think we have not answered, is at the entry level, we may not need programming or some of these skills. But the question is, when they graduate, right? At least in my mind, it is still not clear. What does it mean to have an AI PhD, right? Does it mean that they will be proficient in programming? Or does it mean that they can visualize and understand, they may be not great at programming? So at least that question will have to be answered by some of these centers and schools, right? When they graduate, what are we really looking at?
And I think I will add a follow-up question from my side. I mean, just coming from what Parag is saying. So this programming plus math approach is perhaps okay for the engineering disciplines, I would say, the chemical or something. But if you would like to take the people, let's say from the medicine background or the law background or the agriculture background, even posing this question that you need to know some basic programming and some basic math, perhaps becomes a little too much. Any thoughts on this?
I don't think so. Otherwise they will never understand why AI is wrong.
Okay.
They will never figure out if we don't really teach them some of the basic underpinnings on which AI has been developed. Even though AI is evolving, they will assume that to be a black box and assume everything correct. So I think, like we must understand law to get into law, a lawyer must understand a little bit of this side to get there.
But in this case, are you okay with this person, let's say the law or the medical, not knowing math and programming at the entry level, but as Parag is saying, should know at the graduation level?
Yeah, that is fine. That is fine. Okay. That is fine. But it's not just graduation level. As soon first year, second year only they will have to know.
Right. Okay. Yeah, Ravi.
So we are at the end of the day a technical school, right? So I have to wonder at which point we are going to draw the line, right? So if you're going to take in people, I mean, I'm all for people from a law background and other places to come and work on AI, right? But I'm working with the law schools to make sure that they teach the lawyers more AI in the law schools, right? As opposed to taking in people with a law background into a technical school and then trying to train them, So that has to be a line that somewhere we draw. So that probably will evolve. I don't have a concrete answer for it, but we have to consider that. Okay.
Hi, my name is Anusha. I have a question to kind of Hi, my name is Anusha. I kind of want to expand the discussion not just from the point of view of the education, but also how we can look at collaboration between different disciplines to solve problems. And I come from a maths background. I did my PhD in economics, and then I went on to do my postdoc in blockchain applications. And I found that my knowledge and domain knowledge in economics and statistics really helped me in my research work and postdoctoral work. So my question to all of you is, in terms of problems, and most of the problems that we think that we need to solve are multidimensional problems, whether it's climate change or any which way, where we need all these people to come together from different disciplines to solve it. So do you think AI is going to be the common vocabulary for them to talk to each other, or how do you think we can facilitate those kind of problems which require these kind of huge collaborative efforts to solve?
You worked with doctors, why didn't you start?
No, maybe. I mean, that's the language that will evolve. I mean, we are still seeing lots of exponential evolution of the AI. So I don't think, I don't see any contradiction in your statement. It may well be the vocabulary of the future. I mean, the AI for the common vocabulary.
Okay. So, the point is like this. You're in math. You go to ISI Kolkata, they spend 5 lectures explaining 1 + 1 = 2. All right. Through deep dialogue, probability, theory, axioms, etc. To you, what is 1 + 1 = 2? Anybody needs to spend so much time. Similarly, when different people do AI, everybody doesn't have to understand the same concept at the same level of depth and granularity. So when you collaborate, everybody brings their own depth and understands the others. That is how collaboration really brings the effort together.
I think my question was about how do we develop that common vocabulary where everyone can understand each other, because otherwise...
There is no Esperanto for scientific work, right? So my experience, I have worked with people in traffic engineering, I have worked with people from biosciences, doctors, and everywhere. You have a learning phase where the teams have to learn each other's language, each other's vocabulary, right? And then evolve a common understanding in the context of the problem that you are solving. There's not going to be an universal language in which multiple disciplines can come and talk. It's always going to be in the context of the problem solving that you're doing. Unless the two disciplines work together so often that they develop a more permanent shared language, right? Maybe that could be AI for some disciplines, but I don't think that's a clear answer. I don't think that's a universal answer. You shouldn't be looking for one.
I'm looking for ways to make collaborations more possible.
Talk, be open. And one of the biggest advice I have for people who want to do this kind of interdisciplinary collaboration, right? Don't think that your discipline is at the pinnacle. This is a problem. No, this is a problem I face with everybody. They start with the thing, okay, computer science guys won't understand biology, right? Or these guys are engineers, they won't understand history, the sociology of how cultures interact and things like that, right? Of course, computer science, we know everything, right? So, but no, that's the kind of attitude everybody starts from, right? So I find that that's the biggest roadblock to collaboration. So respect your collaborator, trust them that they know what they are talking about in their discipline, and then there are actual interesting problems that they have to solve in their discipline. Nothing is trivial. That's the first place to start.
Just add, I think regarding AI being thread, I feel that what best we can do is just go with the flow, right? I mean, within AI also there were techniques like SVMs and kernels which were the way to go 20 years back, and now no one is doing them, right? So I think today it seems AI is the thread. 15 years hence, I don't know, right? So I mean, but today let's do whatever is needed. It's clear that multidisciplinarity is the key, and AI seems to be the thread for many of these applications or areas today. But who knows what happens 10 years down the line, right? I would say things will evolve.
Okay, so I think it's 508. So maybe we should. Yeah. So let's thank the panel member and.
Thanks to you.
So as we draw closer to the conclusion of this enlightening session, it is time to extend our heartfelt appreciation to the presenter and panelists who have graced us with their invaluable insights and expertise.